Hello, I'm Balaji Chippada and welcome back to my channel. Let's take an example. You have a lengthy piece of code and you have multiple lines of it. So what usually happens in Python is it will execute the code step by step, and wherever some error happens at that point the execution will get stopped and the remaining lines after that point will not be executed. And that is not what you usually want, right? Even if something unexpected happens inside your code, you would want to handle that exception, or you would want to handle that error gracefully and execute the remaining pieces of code. There might be important steps after that error point, right? So how would you handle this kind of scenario? That is where try and accept comes into picture. So what try will say is, let's say you identified a potential piece of code that might bring errors, and errors are typically of two types. One is of syntax errors that you will get to know while you are coding and debugging and all that stuff. Those are very easy to solve. And second type is basically exception errors. These are very hard to handle, and this could happen for many reasons. Maybe the file that is not present right now, maybe it is present before, and maybe the user input an variable which is of wrong data type, and it could happen for many reasons actually. So these exception errors are usually hard to handle. So what you say is, you say the Python that you will put all of the code which potentially might raise a fault or might raise an error inside a try block, and you say execute these lines only if they are successful. If not, do not execute this piece of code, continue your remaining execution. At that point you also have an option to print what kind of error happened if there is an error happened inside a try block. So this is a lot of theory. So without any delay, let's go into the coding part and understand all the nitty gritty details of try and accept block in Python. Let's say I have this piece of code. Here in the first line I have a equal to 10 and I'm printing a, and then I'm printing hello, and then I'm printing a into 2, and then b equal to 5, and print a by b, and print hello world again. Now let's execute this. So what happened here? Initially, Python compiled a equal to 10, and then it printed a, which is the output as 10, and then it went to the next line, and I print hello world, and then it went to the next line, which is 10 into 2, 20, and then it went into the next line, which is b equal to 5, and then it calculated this 10 by 5, which is the output as 2, and then it printed this, and then it went to next line, and then printed hello world again. So Python executes the code in sequential manner. After every line, the next line will get executed. Now, what happens if some error happens in this piece of code? Let's say I give b equal to 0, and I know I cannot calculate 10 by 0, which will give me an error, but let's execute and see what will happen. If you see, initially a equal to 10, and then print a, I got the output as 10, and then print hello world, I get the output hello world, and then print a into 2, I get the 20. Now it even executed b equal to 10, but at this point, which is 10 by 0, which is an error, it raised an error called zero division error. And because at this point error happened, this line is not executed. The code cell broken at this point. So what happens is, if you have a long piece of code, and at any point of the code, if you have something that might give you an error like this, the next piece of code that is present after the error will not be executed. So these are called exceptions, right? But I want to execute this piece of code even after having an error. How do you do it? That is where try and accept comes into picture. What are exceptions? Exceptions is an error that disrupts the normal flow of a program. Okay. And then when Python encounters an error, it stops the current process and passes it up and stack up until it is handled. If it is not handled, the program will be crashed. Now, what are the different types of errors that we have in Python? Now let's execute this statement, which is print hello world, and this got output. Now what if I didn't give the closing parenthesis? If I execute this, I get an error called syntax error. That means Python is saying that I need to put an closing parenthesis at the end because it is a syntax error. Now let's take another example. Let's say I'm initializing a for loop and I'm executing this. I get hey there 10 times. Now what if I miss this colon at the end? It will raise syntax error again. Or what if I forgot to close this string? Even this, it will raise a syntax error. So let's understand syntax errors in detail. Syntax errors are also known as parsing errors, and these are the most basic types of errors. And these arise and when the Python detects an incorrect statement. Hopefully that is understandable. And primary cause of the syntax errors is basically typing mistake or misunderstanding of syntax of Python. And these are very easy to solve in the testing phase. If I execute this piece of code, I get to know that there is an error in my code. These are very easy to debug, and these are found during the compiling phase. Now you might ask, are there any different types of errors? Yeah, absolutely. Now let's take this example. I'm initializing a variable called number. Inside this, I am asking user to input a number, and whatever the user inputs, I am converting it to an integer. If let's execute this. Here, if I pass a number as 25 or 24 and hit enter, this will not throw any error, and it will print the output as well. At the first time, if user passes the value which is valid, then this is a piece of code which will not throw any error. But what but you cannot expect user to pass every time a valid input, right? What if user enters Balaji here, and if I click enter, I get the error as value error. Before this execution, we see that this is a piece of code which is not raising an error. Now because of some different input, we get the value error for the same piece of code. So these are little bit hard to catch, right? Here it is saying value error invalid literal for int with base 10 Balaji. So these are the types of errors which are very hard to find, and these are called as exception errors. Now let's take another example. Let's say a equal to 5 and I'm printing a, and I'm asking user to enter a number, and I'm doing number into a. Now if I execute this, and if I pass the value as 10 and click enter, this will execute fine. So this is a piece of code that works fine. Now what if user enters something like as bad? This raises a value error again. So this is why we need to handle these errors. You cannot show error directly to the user, right? You need to handle this error some way. Now what are the different types of errors? As I mentioned before, these are called exception errors. They occur even if a statement or expression is syntactically correct, indicating that something went wrong during the execution phase. And exceptions can be handled by using try and except block. And these are the common exception errors that you could find in Python: value error, type error, index error, key error, file not found error, zero division error, and IO error. We will understand all of these errors with examples and where it will happen in detail in a bit. Now let's understand the syntax of try and except block and how we can handle these kind of errors. If you see here in this piece of code, we are getting an error at some point because of some input, right? So this is a piece of code that might raise an error based on the input that is given by the user, right? So what I will say is, I will initialize a try and except block. This is the syntax of it. So I will have a colon, and then I will have to add a piece of code which might raise an error inside my try block. Okay, and then if this piece of code inside try block raises an error, then this will not raise an error. It will go to the except block, and whatever that is present inside the except block will be executed. Now what to add inside except block? Usually inside except block, you are expected to handle the error what is happened inside the try block. You don't want to create one more error inside exception block. On a standard basis, people usually print what kind of error they are having, and they will print some beautiful messages such that it will be understandable for you or for user to handle the error. Okay, and let's take this example: a equal to 10 by 2, and I'm printing the value of a, and if my value of a is equal to 5, I'm printing this, else I'm printing this, and after all of this executed, I'm printing something. So I got all the output. Now what if I give a equal to 10 by 0? This will raise an error in the first line, right? But what if Even though it raises an error, I want to print this statement no matter what. So what I would do is I would add that same piece of code that we have here. See, this is a piece of code that might raise an error, right? Inside my try block, and then I'm saying except exception as e. I will explain this in a bit. And then I'm saying you cannot divide by 0, and I'm printing anything here. You can print whatever you want here. I will just do this here, comment, and I will just comment it here as well. And then I'm using the last statement after this try and accept block. So now let me explain what will happen. So this is a piece of code that might raise an error, right? If this raises an error, then it will go to the accept block and execute this. I will get one more color. If no error in this block, don't execute except block. Okay, and after all of this is done, it will go to the next line, because Python goes sequential printing, and then it will print this statement. Okay, now let's understand this by executing this. So here first let's say a equal to 10 by 0. This will raise an error, right? Now let's try this. If you see, I haven't got any error like this. So first step is we have handled the error. What happened in this scenario? First, Python comes to this try block and it executed this. Because this throws an error, it will not execute any of this piece of code. It will directly jump to the exception block. Now it went to this exception block. We will understand about the exception as e in a bit. And then initially it says print you cannot divide by 0. That is what I got the output. And then because all of this is done, it went into this statement and I got the output here. Now here in this scenario, even though there is an error, you are saying you cannot divide by 0. That is what you are printing. Now let's say I want to do something inside my accept block. I can do this as well. I get the output as 6. You can do whatever you want inside your accept block, but it is recommended to handle the error gracefully. Gracefully means you need to print something or display something which is understandable, saying that you have an error, because of this you got an error. If you read this statement, I can understand that because I have given a equal to 10 by 0, I cannot divide it by 0. That is why it went into the accept block. Okay, now let me do this. Now here in this scenario, you can see that when I do this, I get an error called 0 division error, and the statement output is this one, right? This is the 0 division error, and the message is this one, division by 0. Now what if I want to print that? So that is where exception comes into picture. What I would say is accept exception as e. That means I am saving this value division by 0 inside e, and I can print that as well. Now let's do this. Now let's do print e. Now let me remove this here and let's execute this. If you see now, because there is an error, it went into this block, except block, and then it did a print of e, and I got the output as division by 0. Why division by 0? Because this piece raises an error which is 0 division error, and this is the message division by 0, and we are just printing that by saving that error inside a variable called e. I can even do here Balaji as a variable, but it is recommended to keep it as e because it's an industry standard, and I can do the same thing. I get the same output. See, I hope you understand the essence of try and accept block. Now let's take this one. I'm saying try int xyz. Xyz is a string and I'm trying to convert this into an integer, right? And if I execute this, I get the error as valid literal for int with base 0 and all that blah blah blah. First let's take this and let me create another one and exception as e, and I will execute this. Okay, so in this scenario I'm trying to capture my exception or error inside a variable called e, and I'm printing this e inside my accept block. If you see invalid literal for int with base 10 xyz, let's say you already know what kind of exceptions you might get by looking at this statement int of xyz. I know it raises a value error, and let's say a equal to 10 by 0. By looking at this, I know that this will raise a zero division error, right? So if you already know what kind of error that you will get, you can do this kind of code as well. Try int of xyz, and you know that this will raise a value error. I can say value error as e, and it will go inside this same as this, but you will understand why it is important. Now you can ask, if both are returning the same thing, why are you keeping value error instead of exception? I will come to that in a bit, but let's just go with the flow. Now let's take one more example, which is of type error, and I am saying adding a string to an integer, which is not possible. And if I enter this, I'm saving my exception inside my parameter e, and then I'm printing this. You can only concatenate string but not string. But this is a type error, right? If you see, this is a type error. Now understand this clearly. I know this is a statement that will raise an error called type error. Okay. And if I add exception as e, I get the output as the type error. Now, as I mentioned before, if you already know what kind of exception that you will get, you can add it inside except block, right? But instead of adding a type error, I am saying it's a value error. Okay. So what happens in this scenario is, now let's execute this and understand the output. Here, this raised an error, okay, but it has nowhere to go. Here in this scenario, I am saying go to the except block if it is a value error, but my code is returning a type error, right? That is why even though I have a try and except block, I am getting the error as type error. Now, how do you handle this scenario? So either you copy paste this. Now let me create one more code, and I will say type error. If I add type error here, and if I execute this, I will get the type error message. So it is always recommended to use exception as e if you don't know what kind of error that you get. Okay. Now let's go to the another example, index error. Now I have a my list 1, 2 and 3, and I'm trying to access the third element in my list by using list indexing, and I am doing this statement, and here I get the output as 3. Because try hasn't raised any errors, I get the output as print 3, and then it didn't go to the except block, and then the code went to this line, program continues after handling the exception, and then print 2 plus 3, which is 5. Now what if I give 5 here? I know there is no element for the index 5. Now let's try this, and because it throws an error inside the try block, it goes inside my index error, and I'm printing this. Or else I can just say as e or as e, and then I can do a print of e as well, print of e. Now let's execute this, and I get the list index out of range as a message. Hopefully that is clear. Now one more example, which is key error. Usually keys and values present inside dictionaries. That is why if I try to access my elements inside my dictionary with a key which is not present inside it, it will raise a key error, and then key error caught C. So all of these things you can do using key try and accept block. Now, what if I have a piece of code in which it might raise multiple errors together? Maybe it will raise index error, or maybe it will raise key error, or maybe it will raise type error. It could be any type of error. So how do you handle that scenario? That is where multiple exception blocks comes into picture. The syntax for multiple exception is, you have try, and you can accept, you have exception 1, accept, exception 2, accept, exception 3. So likewise you can have as many exceptions as possible, and inside my try block, if some error happens, it will check what kind of error it is, and if any of that error present inside my exception blocks, it will execute the corresponding exception block. Hopefully that is clear. Now let's take this with an example. Here I have first statement x equal to int input enter a number, and then y equal to 10 by x, and I'm printing x comma y. There are two scenarios it might happen. First scenario is, in this scenario, if x equal to 0, then y equal to 10 by 0 will raise an error called zero division error, right? The next scenario is, during the input that we pass as a customer, if I pass something as Balaji and this cannot be converted into an int, this will raise a value error, right? So this is a piece of code that might raise two errors. One is value error and the zero division error. So what I'm saying in this scenario is, the first except I'm saying zero division error, I'm printing zero division by zero, and the second except I'm saying value error, I'm printing this is a value error. Now let's execute and understand this in detail. Now here I will just give value as 5, and because everything is successful, that means x is 5 and y is 10 by 5, which is 2, and I'm printing 5 comma 2, which is the output. So this is all good. Now what if I give the x as value 0? So that is where I get division by 0. And what if I give x as Balaji and it's saying invalid input, please enter a numerical value, because this is what I print inside my value error. So this is how you can gracefully handle all of your errors inside your code using try and except block. And I can have multiple exception blocks as well. Here I have value error, zero division error, and index error. Now you might ask, why do we need to do all of this? What if I can just do like this, and I will remove this and exception as E, and I will just print E. Okay, now let's try to execute this by giving the value as 0. It is division by 0. Now if I give you the value as Balaji, it is saying invalid syntax. But why do we need these kind of exceptions if this can handle all of this? Now let's say in this scenario, when I pass the value as Balaji, I want my users to know that you cannot pass string. I don't want to print my error. I want to give a message to my customer saying you cannot pass string. That can only be done for specific errors, right? I cannot say this message when it is a zero division error, right? Zero division error is not related to this one. If it is a value error, then only print this statement. If it is a zero division error, I will say don't input value as 0, because it throws a zero division error. So if I want to handle different kinds of messages for different kinds of errors, that is where multiple exception blocks will be useful. If I do here, let's say print don't enter 0. Okay, now let's try this. I will enter Balaji. Even though the error is a value error because of string type conversion, I'm printing don't enter a 0. That is not good, right? So that is where it is beneficial to handle different kind of exceptions that you know with different kind of messages. Let's understand one more important thing, which is finally. So it's basically simple here. No matter what happens inside this try and except block, finally whatever the piece of code inside finally will get executed. That's it. Very easy. Even if try gets successful, that's good. If there is an error inside try, except it will go into except, the code inside except will execute, and then it will execute finally. No matter what happens between try and except, finally will get executed. Now let's take this example. Now let's enter this. So because here what I'm doing is I have a list of strings, and in this first line I am converting all of this into integers, and I'm summing up all the values, and I'm printing the sum, and I am saying if there is an error, go inside the except block. Okay, because in the first time, based upon my input, there is no error and I get the output as 166, and it didn't go into the except block, and it went into the finally, and then it printed attempted to calculate the sum. Okay, now what if I give a here, and this cannot be converted into an integer, right? And if I execute this, try will throw an error, so it will go into this except block because it is a value error, and it will print this list contain non-numeric values, and then it went into finally attempted to calculate the sum. So no matter what you do, finally will always be executed. So that's it, guys. In this video, we learned what are exceptions and what are the different types of exceptions and why do we need to handle these exceptions and what is the syntax of try and except block. And we have seen multiple scenarios where we can use this try and except block, and we have also learned about multiple exception block, and then finally we learned about finally. In this video, we summarized everything and we learned everything about it. Hopefully you learned something new from this video, and we will meet you in the next video. Bye bye.